Okay, so these are GCSE questions based on angles in and around parallel lines. So here's question 1. The first question is about perpendicular lines, finding an angle. And the second part is about a pair of parallel lines, angles formed around them. You can see there's a reasoning question there, and there's a question explaining why the sum of angles is 235 degrees. Okay, so question 1, it says AB and BC are perpendicular lines. Find the value of x. Well, straight away what you should do here is you should underline the word perpendicular. Okay, and you know that means at 90 degrees. And so to find the value of x, you know that because these are perpendicular, the sum of all of these angles is 90 degrees. So there's a right angle there. So you can quite simply find the value of x by saying that all three angles sum to 90 degrees. So therefore x is 90 minus those two angles. 90 minus 25 minus 25. That will give you 40 for 2 marks. Okay, and the second part says RS and 2U are parallel lines. So the first thing you do is underline parallel. PQ is a straight line and that cuts through them. So that's called a transversal. Okay, and that line there is the most important line in this diagram. Okay, because around that line you've now got 4 angles that are formed here, and you've got 4 angles formed here, and some of those angles are labelled up and some of them are given to you as values. This angle here is given to you as 125 degrees. Okay, and you've got to write down the letter of one other angle which is also 125 degrees. You've got to give reasons for your answer. Okay, so there's 2 possible answers for this. The first answer that you could have is that B equals 125 degrees because vertically opposite angles are equal. So these 2 angles are vertically opposite, they're equal. Or you could give it a reason that D equals 125 degrees because corresponding angles are equal, because they're on the same side of this transversal, they're corresponding angles, and you can see that they look the same as well. Okay, they both look like obtuse angles which are equal, and therefore that is why that is 125 degrees. And the last part of this question, explain why A plus B plus C equals 235 degrees. So explain why these 3 angles sum to 235 degrees. Well, you know that all 4 of these angles are angles around a point, and so they would all sum to 360. So that's the big clue there. So what you do with this question is you'd say that those are all angles around a point, and so since the sum of all angles at a point is 360 degrees, then those 3 angles are going to be 360 minus 125, which is essentially 235 degrees. So that is why they sum to 235 degrees. And so that is 5 marks altogether for all of that question. Okay, so question 2 states that the diagram shows a quadrilateral ABCD. And so for 3 marks, you've got to explain whether or not AB is parallel to DC with full reasoning. Okay, so with this question, I would underline the word parallel, and you should know that parallel means that the lines go in exactly the same direction. So does the line AB, this line here, go in exactly the same direction as CD? So there's no point in saying that it looks different, okay, because remember these diagrams are not drawn accurately unless stated, okay? So you can't just say it looks different, it doesn't look parallel. You've got to use these angles here. Now if it's parallel, these 2 angles would sum to give 180 degrees, okay, because they'd be called co-interior angles. So these 2 angles here, do they sum to 180 degrees? Well, no, they don't. They sum to 177 degrees, okay, so therefore these are not co-interior angles, so therefore line AB and line DC are not parallel, okay, they are not parallel, and that would be 3 marks for that question. Okay, so question 3, and it's a 5 marker, okay, so it's a big question, this one is, and it is again about parallel lines. It says that BC, so BC, this line here, and DEF are parallel straight lines. So I'd underline the word parallel and I'd underline the word straight, okay, so they're parallel straight lines. ABE is an isosceles triangle, so underline the word isosceles, with AB equal to BE. Okay, so that is there in effect the top of your isosceles triangle. and this angle are your base angles. Okay, it also tells you that angle CBE is 142 degrees. So this angle here is 142 degrees. Work out the size of angle X. So work out the size of this angle, giving a reason for each stage you're working. Well, because this is parallel to this, okay, I'm going to first off start by working out this angle here, and then I'm going to find this angle here, and then I'm going to use that to find angle X. This is how I'm going to do it. Okay, first of all, because this is a straight line, I know that this angle here, angle ABE, that I've labeled as angle 1, I know that it's going to be 28 degrees, since 28 add 142 gives 180. So that's angle 1. Okay. Secondly, since ABE is a triangle and it's an isosceles triangle, okay, I can find the sum of these two angles by doing 180 minus this angle I've just found. And well, that gives us 142 again. So 142 is the sum of these two angles here. But these two angles are going to be equal, remember, because it's an isosceles triangle. Okay, it's just turned on its side. So, because these are equal, I can then divide 142 by 2 to give me 71 degrees. So this angle 2 here is 71 degrees. Now, I'm going to use the fact that line A, B, C and line D, E, F are parallel. And because they're parallel, these two angles, so angle 2 and angle X, are going to be alternate angles. And alternate angles are always equal. Okay, so because they're equal, angle X is also going to be 71 degrees. Okay, so that is 5 marks for that question. I'll just zoom out so you can see it. Okay, best of luck. Okay, question 4, it's a 4-mark question, and it states that ABCD is a quadrilateral. And it tells you that AB equals CD, so that line is equal to that line in length, and you can see that from those markings there. And it also tells the angle ABC, so this angle here, is equal to angle BCD. Prove that AC, so this imaginary line, the diagonal from here to here, is equal to the imaginary line from this diagonal BD. So prove that these two diagonals are equal. Okay, so for 4 marks, the way I would do this is I'd think back to congruent triangles. So think back congruent triangles and think of the side angle side rule. Okay, side angle side. So what I'm going to do here is I'm going to draw on these two lines which I need to prove are equal. Okay, and the way I'm going to prove they're equal is I'm going to prove that triangle ABC is congruent to triangle BCD. Okay, first of all, I'm going to prove that they've got an equal side, and the equal side is length AB, and that is equal to length CD. So these two sides are equal on these two triangles because it tells you that in the question. Okay, the next part, I'm going to prove that they've got an equal angle. So an equal angle they've got is angle ABC in this triangle is equal to angle BCD in that triangle. Okay, so that's proved the angle. And finally, the third side, which includes the angle, so the third side is the side BC. The side BC is a common side for both of these two triangles. It's a common side. Therefore, okay, they've got an equal side, another equal side, and the angle between those two sides. So therefore, those two triangles are congruent. Okay, that proves then that AC, which is this diagonal here, is equal to BD, that diagonal there. So those two diagonals must be equal because of congruency, and that is 4 marks for that question. Okay, so question 5, it's a 4-mark question, and it states that ABCD is a parallelogram, so ABCD is there, EDC is a straight line, F is a point on AD, so F is a point on that line there, so that BFE is a straight line. BFE is a straight line. Angle EFD equals 35, that's the angle there. Angle DCB equals 75. Show the angle ABF, this angle here is 70 degrees. Give a reason for each stage of your working. Okay, so what I'm going to do first of all is I'm going to find this angle here, angle 1, as I'm labeling it here. I'm going to find angle 1. Then I'm going to find angle 2, and then I'm going to find this third angle in that triangle. Okay, So first of all, because vertically opposite angles are equal, I know that angle 1, this angle AFB here, must be the same as angle EFD, 35 degrees. So there's my reasoning. That sentence needs to be written down. Secondly, okay, because this is a parallelogram, shape ABCD is a parallelogram, I know the opposite angles in a parallelogram are equal. So therefore, this angle 2 must be 75 degrees. Okay, so angle FAB is 75 degrees. Okay, now that I've found two angles in that small triangle there, I can find the third angle by just subtracting those two angles from 180. So that would give me 180 minus 35 minus 75, which is 70 degrees. 70 degrees would give you the answer, and with all the reasoning, you would get the 4 marks for that question. Okay, question 6, and it's a 3-mark question, and it states that ABCD is a parallelogram, and it says that E is the point where the diagonals AC and BD meet. Okay, prove that the triangle ABE is congruent to CDE. So prove that this small triangle here is congruent to that triangle there. Okay. So the way I'm going to prove congruency is I'm going to use the angle side angle rule. Angle side angle. Okay. First of all, with parallelogram, you know the opposite angles are equal and opposite sides are equal. Okay. So you need to make a note of that. So first of all, to prove the angle side angle rule, I'm going to prove the first angle, which is the angle ABE. This angle here is equal to angle CDE, and because alternate angles are equal, and these are parallel lines cut by this transversal, so these two angles are equal. Okay. Secondly, for these two triangles, I'm going to prove that they've got an equal side, and the equal side here is AB, which is equal to CD. Those two sides are equal because, as I mentioned earlier, opposite sides in a parallelogram are equal, so those two sides must be equal. Lastly, the second angle is going to be angle BAE. BAE is equal to DCE because, again, alternate angles are equal. Okay, this time here's your parallel lines, this time here's your transversal. Okay, so again, these two angles are alternate angles. Okay, so with all those together, you've proved that angle side angle, so therefore those two triangles are congruent to one another, and that would give you 3 marks. Okay, question 7, a 3-mark question. AE, DBG and CF are parallel. Okay, and you've got length DA, which is equal to DB, which is equal to DC. So these 3 lengths are equal, and you can see that from the markings on the diagram. Angle EAB equals angle BCF. So these two angles are equal. Okay, work out the size of the angle marked X. You must show you're working. Okay, so for 3 marks here, first of all, I'm going to find angle 1, as I've labelled it here, this angle here. Then I'm going to find angle 2. Then I'm going to find angle 3. And then I'm going to use angle 3 to find angle X. So first of all, let's find angle 1. Well, since alternate angles are equal around parallel lines, okay, I can say that this angle 1 is the same as this angle here, because these two angles are alternate. Because here's your two parallel lines, and here's a transversal. So these two angles are on opposite sides of that transversal. They must be alternate angles. As you can see, they look the same as well. Okay, so therefore, that angle there is 38 degrees. Secondly, I'm going to find this angle here. Okay, so to find that angle there, well, because this triangle here has got 2 equal sides, so side DC is equal to DB, it's an isosceles triangle, and 2 base angles are always equal in an isosceles triangle. Okay, so what I can do there is I can just say that angle 2 is equal to angle 1. Okay, because they're 2 base angles in that isosceles triangle, so angle 2 must be 38 degrees. Lastly, to find angle 3, and then I'm going to find my final angle X. So angle 3, again, I've got a triangle here. Okay, I've just found the 2 angles. To find the third angle, I'm going to subtract those 2 angles from 180 degrees, and that will give me 104. So angle 3 is 104. Now, finally, because you can see this diagram is completely symmetrical, okay, because this length AD is the same as DC, this angle 38 is the same as that angle 38, okay, this entire diagram is symmetrical, therefore I know that this angle here is going to be the same as the angle 3 which I've just found. So I know essentially these two angles. So to find the third angle, the angle X, I'm just going to use the angle fact of sum of angles around a point. And I know that sum of angles around a point is 360 degrees. So therefore, 360 minus 104 for that angle, minus 104 for that angle there, would give you 152 degrees. And that would be 3 marks for that question. You've got to give all the reasoning, and if you get that answer, you'll get your 3 marks. Okay, question 8 is a 5-mark question, okay? And it actually involves forming and solving equations along with angle facts. Okay, so there's a parallelogram there, and we're asked to work out the value of x and the value of y. We're not given the lengths of any sides. All we're given are some angles, and we're given those in algebraic form. So they're basically represented, some of them are represented by unknowns. Okay, so for this question, I'd underline the word parallelogram and recognize that opposite angles in a parallelogram are equal, and obviously adjacent angles in a parallelogram are co-interior angles. Okay, so these would add to those would sum to 180 degrees. So the steps in this question are: I'm going to form an equation and solve it to find x. Then I'm going to form a second equation and solve it to find y. So let's form the first equation. To form the first equation, I'm going to say that these two opposite angles are equal. Okay, they must be equal. So 5x minus 20 must equal 2x plus 43. So I've formed an equation there. Now I need to solve that equation. So I'm going to subtract 2x from both sides, okay, using the balancing method. That leaves me with 3x minus 20 equals 43. And then going to do the inverse of subtract 20, which is add 20 to both sides. That'll give me 3x equals 63. Then I'm going to do the inverse of multiply by 3, which is divide by 3 on both sides, which will give me x equals 21. So I found the value of x, so I can write that in there. Now, I now need to find the value of y. To find the value of y, I'm going to form another equation, and I'm going to solve that. Okay, so to form the next equation, I'm going to use the fact that these two angles here are next to each other in that parallelogram. So they must sum to 180 degrees. Okay, so I can do 5x minus 20 add 4y minus 5x equals 180. So now if I just tidy up this equation by collecting like terms, well, this 5x cancels with this negative 5x, so I'm left with negative 20 plus 4y. That equals 180, because these two terms have cancelled each other out. 5x cancels out negative 5x. Now to solve this equation, I'm going to use a balancing method. I'm going to add 20 to both sides. That leaves me with 4y equals 200. I'm then going to divide both sides by 4, because that's inverse of multiply by 4. That leaves me with y equals 50. So y equals 50, x equals 21, and that would be 5 marks for that question. Okay, question 9 states that BEG is a triangle. A, B, C, and D, E, F are parallel lines. Work out the size of angle X. So work out the size of this angle here. Give a reason for each stage of your working, and you'd get the 4 marks when you get the answer as well. So for this question, you need to recognize that this is a triangle. So you need to recognize that angles in a triangle sum to 180 degrees. There's parallel lines. You need to recognize where you've got alternate angles and corresponding angles, perhaps co-interior angles. This is how I'm going to do the question. Okay. First of all, I'm going to find angle 1. Then I'm going to find angle 2. Then I'm going to find angle 3. Then I can use those answers to find angle X. That's my final answer. So, first of all, angle 1 is found by recognizing these two angles are co-interior, okay, because they're on both sides of this transversal, and your parallel lines are here. Okay, so these two angles would sum to 180 degrees, therefore angle 1 is 70 degrees. Secondly, I'm going to find angle 2. Angle 2, I can find it because these three angles are all adjacent on a straight line, and because they're adjacent on a straight line, they would all sum to give 180 degrees. Okay, So I can do 180 minus the angle I've just found, minus the angle I'm given here, which would give you the answer for angle 2. So that would be 75 degrees. The third angle I'm going to find is this one here. To find this angle, I'm going to do exactly the same thing, but for this side here. These three angles are all on a straight line, so they sum to give 180 degrees. So 180 minus 110 minus 25 would give you 45 degrees. Lastly, to find angle X, I've just found the other two angles in this triangle. So to find the angle X, I know that the interior angles in a triangle sum to give 180 degrees. Therefore, 180 minus 75 minus 45 would give you 60 degrees for 4 marks. You've got to have all the reasoning there, and the answer would give you those 4 marks. Okay, so question 10 states that ABCD is a parallelogram. ABP and QDC are straight lines. So these are straight lines. Okay, and you must know that they're parallel because they're part of this parallelogram. Angle ADP equals angle CBQ. So ADP is equal to CBQ, which both equal 90, and that's marked on the diagram. Okay, prove that angle ADP is congruent to triangle CBQ. That's the first part, that's part A. And part B, explain why AQ is parallel to PC. AQ is parallel to PC. So the whole question there is 5 marks. For the first 3 marks, we need to prove that the two triangles are congruent to one another. So for the congruency, I'm going to use the angle side rule. Angle side. Okay, so let's look at that. So first of all, the first angle which is equal in both of these two triangles, this blue triangle and this green triangle, okay, is angle ADP. So ADP is 90, and angle CBQ. CBQ is also 90. So therefore, those two angles are equal in the two separate triangles, and it tells you that in the question anyway. The second thing is another angle, and that is this angle here, so angle DAB. I'm going to prove that's equal to angle ADQ. ADQ, okay? So these two angles are equal, okay, since alternate angles around parallel lines are equal. So these two angles must be equal. And since angle ADQ is equal to angle BCD, because of corresponding angles are equal, okay, this angle must equal that angle. So angle DAB must equal angle BCD. They're in those two separate triangles. So I've proven now the right angles are equal in the two triangles, and these two angles are equal in the two triangles. The last thing I'm going to prove is they've got an equal side, and the equal side is the length of AP, and that equals CQ. And how do I know that they're equal? Well, it's because they're part of this parallelogram. Opposite sides of a parallelogram are always equal. So therefore, those two lengths must be equal. So I've proven there the two angles and the side are equal in those two separate triangles. That would give me my 3 marks. Okay, so for part B, I'm going to explain why AQ is parallel to PC. So AQ is parallel to PC. Well, they're parallel, okay, because they're at the same angle. And angle AQD is equal to angle BPC. So AQD, okay, so this angle here is equal to angle BPC. It's equal to that angle there. So that angle is equal to that angle because opposite angles in the parallelogram are equal. Okay, so because the opposite angles are equal, then therefore these two sides are at the same slope, therefore they're equal. Okay, so both questions are very, very much related. Okay, but they'd get you 5 marks with all those reasons given. Okay, so question 11. Okay, it's arguably the hardest question on this booklet. Okay, and it's a 4-mark question. So it states that in the diagram ABC, so ABC and DEFG are parallel lines, and you can see that from the markings there as well. Angle ABE equals X degrees, that's marked there. EB equals EF, so EB is equal to EF. So straight away you can see you've got an isosceles triangle formed here. Okay, and also the angle W, well, you have to show that angle W is related to angle X through this equation here. So W equals 90 plus a half X. You have to give a reason for each stage of the working, okay? And like I said, that question is worth 4 marks. So how are we going to do that? Well, first of all, I'm going to find this angle down here. So I'm going to find angle 1. Then I'm going to find angle 2, as I've labelled it here. Then I'm going to use that to get an equation for angle W, okay? So, first of all, let's find angle 1. Well, since alternate angles are equal, okay, angle 1 is going to be equal to that angle there, x. Okay, so that's straightforward. Angle 1 equals angle x. Now, secondly, to find angle 2. To find angle 2, well, I know that this is an isosceles triangle. I know that this is an isosceles triangle. So since it's an isosceles triangle, okay, these two angles, okay, must be the base angles of the triangle, and this must be, in essence, the top angle of the triangle. Okay, so to find angle 2 here, I'm going to do 180, which is the sum of all three angles, subtract the angle 1, and then divide by 2. So I'm going to do 180, subtract that angle, and then divide by 2 because this angle and this other base angle must be equal. So I'm going to divide it by 2. So that would give me 180 minus x divided by 2, because this angle is x, remember. Okay, so 180 subtract x divided by 2. And that's all I can find for angle EFB. I have to leave it in that form. Okay, so it's in a bit of a funny form. That's how I have to leave it. Now, I'm now going to find angle W. Well, angle W, it's related to angle 2 since they're both adjacent angles on a straight line. So they both must sum to give 180 degrees. So because they sum to give 180 degrees, okay, I can say that angle W is 180 subtract angle EFB. This is 180 subtract that. So that would give me 180 subtract the expression here. So I've substituted that into there. You have to be really careful here. There's a tricky part. I've got 180 subtract this fraction. Now, I can rewrite this fraction as 180 divided by 2. And then I've got a negative x divided by 2. But because I've got a negative sign in front of the whole fraction, it changes the sign of everything here. So I end up with 180 subtract 90, which is 180 divided by 2. And I've got a subtract negative x over 2. And if I'm subtracting a negative, I end up with a positive. So this ends up with 180 minus 90 plus x over 2. So I'm going to simplify this. That gives me 90, because 180 minus 90 is just 90, plus x over 2. And they want it written in this form, 90 plus half x. We know that this is essentially the same as this. It's just written in a different form. A half x is essentially the same as x divided by 2. So that would give you 4 marks there. But this really is the tricky part here. A lot of pupils got this wrong by not recognizing this negative sign in front of this whole fraction. That changes the sign of everything inside this fraction here. So that is 4 marks for that question there.